to discuss our fourth problem under partial derivatives. The fourth problem is if u equal to x power y, if u equal to x power y, then we have to show two results. That is, first result is, we have to prove two results. That is, first result is dou square u divided by dou x dou y equal to dou square u divided by dou y dou x. Second result, second result is u x y equal to u x y x. These are the two results that we want to prove in this problem. So now we enter into the solution part of the problem. Now, so here what is u? U equal to x power y. U equal to x power y. So it is in the form of f of xy, f of x comma y. So function of two variables, f of xy. So function of two variables. But is it possible to find dou u by dou x and dou u by dou y? Means in this format it is not possible, because in differentiation we are having two scenarios. One is d by dx of a power x. There is another thing called e power x, but now I am not going to discuss anything about e power x, because differentiation of e power x is e power x itself. So I am not going to discuss about that. Now I am going to discuss about only a and x. That is a power x and x power a and x power a. And x power a. So what is differentiation of a power x? A power x log a. A power x log a. A power x, a power x, yes. The differentiation of a power x is a power x log a. It is usually natural log. So the problem is a power x natural log a. Natural log a. It is usually natural log, but usually in school we used to write a power x log a, because the school students are not aware of this natural log. But in my previous video itself, I have previous video means in one of my videos I have explained the difference between this natural log and common log. One is common logarithm and another one is natural logarithm. So you have to go through it. So the natural logarithm is having the base e and common logarithm is having base 10. That is a very important difference between both natural logarithm and common logarithm. Now here in x power a, we will have the derivative as a x power a minus 1. A x power a minus 1. A x power a minus 1. So what is the thing here means? So here you can see the function u depending on two variables x and y is purely in the format of base and power. Here both base and power are variables, but in differentiation it is not possible to deal with both base and power as variables. At least we should have one constant. Either constant may be in the base or constant may be in the power. If constant is in base, then the variable will be in power. If constant is in power, then the variable will be in the base. So it is not possible to differentiate the function having both base and power as variables. At least we need a constant. Also, it is not possible to differentiate any function having two constants, that is constant base and constant power. So if it is so, it is constant itself. For example, if I write 2 power 3, it is constant again, so it is 8. So differentiating that constant will give 0. So it is also not a big deal to solve, but when it is like x power y or y power x, means it is very tough to solve the problem in that format. Okay, now we need to change this format. So for changing this format, we will have we can try two different cases. That is, let me explain one case here, so which I am not going to use. So u equal to x power y. If possible, you can please go through it, but I am not going to this, but I am explaining in how many ways we can solve a problem. Okay, see here, u equal to x power y means we can take simultaneously e power log, that is without loss of generality. We can write the above equation as follows: e power log u equal to e power log x power y. So e and log will get cancelled, means we get u equal to e power y log x. So after this we can find dou u by dou x or dou u by dou y, etc. Okay, dou u by dou y, etc. But I am not going to use this kind of format. I am not going to use this kind of solving a problem. I am going to take simply, so here we have taken both e and log simultaneously, but here I am going to take only log. So one thing is, in this scenario here having u alone, so we can directly get dou u by dou x and dou u by dou y, whereas in the following trial we will have log u. Okay, log u equal to log x power y. So in the next step we will have log u equal to y log x. So this can be obtained after this step also. So taking log on both sides, both log and u will be cancelled. So we get y log x. So we get y log x. Okay, now here we will not get dou u by dou x directly. So this is our important equation. Now we take this equation as 1. This equation as 1. So now partially differentiating, partially, that is important, partially differentiating equation 1 with respect to x and partially differentiating equation 1, okay, equation 1 with respect to y. Okay, so here we get log u. U is function of x and y, so we get log u as 1 by u, and again this you have to differentiate with respect to x, so dou u divided by dou x, that is equal to, here since we are differentiating with respect to x, we can take y as constant, and differentiating log x we get x, so dou u by dou x, equal to u y divided by x, and here we will have 1 by u, okay, 1 by u dou u by dou y, okay, dou u divided by dou y equal to, so with respect to y we are differentiating, so now this can be differentiated to give 1 by u, equation can be differentiated to give 1 by u dou u by dou y on left hand side, that is equal to, here what is constant, this x, log x is constant, so we get only log x because y will become 1 on differentiation, so log x. Okay, now we have dou u by dou y, okay, dou u by dou y equal to dou u by dou y. Now we are having dou u by dou y equal to, this dou u by dou y equal to u log x, okay. Now we have to differentiate this once again, so this is nothing but our ux, this is our ux, and this is our uy, okay. Now we have to differentiate this again with respect to x, that is our, we are differentiating partially the equation number 2, we are differentiating partially equation number 2 and equation number 3 with respect to x and y respectively, okay. So here we want to find with respect to y, so uyx, and here we want to find uxy, because we have to understand one thing, in this second condition, if we are having u x x y means first we are differentiating u with respect to y, and then we are differentiating u y with respect to x, and after that we are differentiating u x y with respect to x. Here we are differentiating u with respect to x. After that we are differentiating ux with respect to y to get uyx, and after that we are differentiating this uyx with respect to x. Okay, so that is the way we are giving notation in the format of ux, uxxy and uxyx. Okay, you have to get a clear idea about that. So uyx means nothing but nothing but dou square u divided by dou x square, dou square u by dou y dou x. Okay, dou y dou x, that is what we want to find. And here uxy means dou square u divided by dou x dou y, dou x dou y. So this is nothing but dou divided by dou y of dou by dou y of dou u by dou x. Okay, and this is nothing but dou by dou x of dou u divided by dou y. Okay, we are differentiating partially equation 2 with respect to y and equation 3 with respect to x. Okay, now we want to find these values. So here dou by, we are going to differentiate with respect to y, dou by dou y of what is the value of dou u by dou x? The value of dou u by dou, okay, the value of dou u by dou x. Okay, and here the value of dou u by dou y. Okay, so the value of dou u by dou x is u y divided by x, uy divided by x. Here the value of dou by dou x of the value of dou u by dou y is u log x. Okay, so here we have to do very carefully further. Okay, here what is constant So 1 by x is constant. 1 by x is constant. U is not constant because U is function of two variables, both x and y, and y is also not constant. Okay, so U into y means x into y means what we can do, sorry, U into v means uv dash plus v dash, uv dash plus v dash. So we write here 1 by x of u into 1, okay, u v dash plus v, that is y into dou u divided by dou y, dou u divided by dou y. Okay, and here and in here we can take, we are not supposed to take anything outside. We are not supposed to take anything outside because here log x is a function of x as well as u is also a function of both x and y. So here uv dash plus v dash means u v dash. On differentiating log x we get u by x, u by x, u v dash plus v dash plus v into u dash, that is log x, okay, log x into dou u, okay, dou u divided by dou x, dou u divided by dou x, that is equal to 1 by x. The value of u is x power y, and now plus y divided by, here we are having x, y by x into dou u by dou y. What is dou u by dou y? The value of dou u by dou y is u log x, so u log x means the value of u is x power y log x, okay, x power y log x. What about here? Here we are having the value of u is x power y divided by x plus log x is again log x. What is dou u by dou x? Dou u by dou x, so that is u y by x, so u into y by x, so u y by x means x power y u, that is u into y divided by x, that is equal to x power y minus 1, okay, x power y minus 1 plus x power y minus 1, okay, what y x power y minus 1 into log x, here x power y minus 1 plus again, so y into x power y minus 1 into log x, y x power y minus 1 into log x into log x. Okay, so this is our dou square. Okay, dou square y dou square u by dou x, dou square u divided by dou y dou x. Okay, and this is dou square u divided by dou x dou y. So these two equations are equal. So that is 4 equal to 5. 4 equal to 5. This is 4 and this is 5. So 4 equal to, therefore equation 4 equal to equation 4 equal to 5. It implies dou square u divided by dou y dou x equal to dou square u divided by dou x dou x dou y. Okay, so this is our first result. First result is proved. Okay, is okay, the first result is okay. Now these two are equal, these two things are equal means, and we are going to differentiate these two things. Okay, with respect to x again. So the first, this can be written as u y x. Okay, and this can be written as u x y. Okay, now I am going to write, I am taking this equation as 6. Okay, the equations are the left hand side and right hand sides are equal. The left hand side is equal to right hand side, and I am going to differentiate both sides by using the same variable. So partially differentiating equation 6 with respect to x on both side we get u x y x equal to u x x y. So this is our second result, and it is also proved. It is also proved. Okay, this is also proved. I hope you all understood the problem, and this problem is very important, because by using this problem only we are seeing that uxy equal to uyx. Okay, so this problem is very important, because uxy equal to uxy equal to uyx under some certain conditions is what we have seen yesterday. So but now it is explained with a problem. So this problem is very important, so kindly go through it. I hope you all understood this problem. Thank you all once again for watching this video.